Hey there, fellow space explorers. Ready for another deep dive? Today, we're going to be tackling the awesome universe we live in, from constellations to planets to galaxies far, far away.
Sounds like a blast. I'm ready to explore.
Okay, so first up, something I've always wondered about. Constellations.
Ah, yes. Those beautiful patterns in the night sky.
Right, so they're like pictures in the sky, right? Made of stars. But,
Yeah.
did people really think those stars were actually connected? You know, like a giant dot-to-dot puzzle.
That's a great question. And you're right. Way back in the day, people looked up and saw these patterns and, well, they used their imaginations. They connected the dots and created pictures, just like a giant connect the dots game. They saw all sorts of things, figures and characters from their stories, like Orion the Hunter or Ursa Major, the Great Bear.
Oh, yeah, I've heard of those.
And, they even use these constellations for navigation, like a map in the sky, But here's the thing. We know now that those stars aren't actually connected.
Yeah.
Nope. They're incredibly far apart. But from our view on Earth, they look close together.
Ah, okay. So they look connected, but they're not really.
Exactly. So while we still use those old names and stories, we now define a constellation, well, more specifically, it's a specific region of the sky, kind of like dividing a pizza into slices. Each slice is a constellation.
So it's like the name stuck.
Yeah.
Even though we learn more about what constellations really are.
You got it.
That makes sense.
Yeah.
But how did they decide on which constellations are like official? Is there like a space government that makes these decisions?
Well, not a space government exactly, but there is an organization called the International Astronomical Union, the IAU.
The IAU.
Think of them like the referees of space.
Okay.
Back in the early 1900s, they wanted to make things official, organize everything. So they looked at all the different constellations that people had been using over centuries and from different cultures all over the world.
Wow.
And finally, they agreed on a list of 88 official constellations, dividing the entire sky into 88 regions. It's like creating like a universal map of the sky, you see.
88 constellations. Wow. It's a lot to find. I've always wanted to try stargazing, but it seems kind of hard. Like, where do I even begin?
Well, stargazing is a wonderful hobby, and it's easier than you think, really. First step is to find a nice dark spot, away from all the city lights.
Ah, yeah.
You see, cities have a lot of light pollution, which makes it harder to see those fainter stars. Imagine trying to see a firefly next to a giant spotlight.
Oh, yeah. Makes sense.
The spotlight makes it much harder to see that firefly's light, right?
Right.
So the darker the location, the better for stargazing. Simple as that. It's also best to pick a night when there's no moon.
Because the moon is too bright.
Exactly. The moon's light can be very bright and wash out the stars. Oh, and one more thing. Give your eyes time to adjust to the darkness.
How long does that take?
About 30 minutes. Once your eyes adjust, you'll be able to see way more stars.
That makes sense. So find a dark place, no moon, and let my eyes adjust. Got it. But how do I actually find a constellation? The sky's so big.
Yeah, it can seem overwhelming, that's for sure. A good place to start is with the Big Dipper.
The Big Dipper.
It's one of the easiest constellations to spot, especially in the northern hemisphere.
Oh, yeah, I've heard of that one.
It looks like a giant ladle or dipper in the sky. Hence the name.
But how do I find it?
Well, it changes position throughout the night and year, but during summer nights, it's usually high in the northern sky.
Okay.
Once you find it, you can use it to find other constellations, like using a map to navigate,
So it's like a guide.
Exactly. A celestial treasure hunt.
That sounds fun. Okay, so I find the Big Dipper. Then what?
Well, the Big Dipper can help you locate the North Star, also known as Polaris.
Polaris.
If you look at the two stars at the end of the Big Dipper's cup, imagine drawing a line straight up from them, about 5 times their distance apart. That line will lead you right to the North Star.
Oh.
The North Star is special because it always appears in the same spot in the night sky, pointing north. This is why sailors and travelers used it for navigation for centuries.
Wow, that's really neat. So I can use the Big Dipper to find the North Star. What else? Are there any other constellations I can find from there?
Absolutely. Once you've found the North Star, you can use it as a reference point to find other constellations. It's like connecting the dots in a cosmic puzzle.
Cool.
For instance, there's Cassiopeia, which looks like a big W or M, and Ursa Minor, the Little Dipper, which is fainter than the Big Dipper, but has the North Star at the end of its handle. And that's just the beginning. There's a whole universe of constellations waiting to be discovered.
I'm definitely going to try to find some constellations tonight. But there's more to space than just stars, right? What about planets? I'm really curious about our solar system, the sun. and all the planets that go around it.
You're right. Our solar system is like a tiny neighborhood in the vast universe. And at the center of our solar system is the sun, our very own star. It's a giant ball of hot gas that produces all the light and heat we need here on Earth.
So it's like a giant furnace.
In a way, yes. It keeps us warm and gives us energy.
Okay, so the sun is a star and Earth is a planet that orbits or goes around the sun. Got it. But how many planets are in our solar system, and what are they like? Are they all like Earth, or are there some really weird ones out there?
There are 8 planets in our solar system, and you're right, they're not all alike. Each planet has its own unique personality and characteristics, you could say. Let's start with the 4 planets closest to the sun, which are called the inner planets.
Okay, so 4 inner planets. Tell me more.
The closest planet to the sun is Mercury. It's a small, rocky planet that zips around the sun faster than any other planet. Think of it like a little speedster. Next is Venus. Venus is often called Earth's twin because it's similar in size. But don't be fooled. It's a scorching hot planet with a thick, toxic atmosphere, like a superheated pressure cooker. Then we have our home planet, Earth, the only planet we know of that has liquid water on its surface and an atmosphere we can breathe. Finally, there's Mars, the red planet. It's known for its reddish-orange color because of all the iron oxide or rust in its soil.
Wow, those inner planets are pretty different from each other. What about the other 4 planets?
The other 4 planets are called the outer planets, and they're much larger than the inner planets and are made mostly of gas. The first one is Jupiter, the largest planet in our solar system. It's so big that you could fit over 1,300 Earths inside it. Next is Saturn, which is famous for its beautiful rings. These rings are made up of ice and rock, and they look like a giant flat disk around Saturn.
Saturn's rings are amazing. I've seen pictures of them. What are the last 2 outer planets?
After Saturn comes Uranus, which is a giant icy planet that's tilted on its side, so it spins like a rolling ball. And last but not least, we have Neptune, the farthest planet from the sun. It's known for its deep blue color caused by methane gas in its atmosphere and for having the strongest winds in the solar system.
Whoa, 8 planets, and they're all so different. It's like a giant family with each member having their own unique personality. But is that all there is in our solar system, or are there other things floating around out there?
You're absolutely right. It is like a giant family. And besides the sun and the 8 planets, there are other objects in our solar system too, like moons, asteroids, and comets.
Moons, asteroids, and comets. I've heard of those, but can you explain what they are?
You bet. Moons are natural satellites that orbit or go around planets. Earth has 1 moon, but some planets have dozens.
Dozens of moons. That's crazy. What about asteroids?
Asteroids are like giant space rocks. Most of them hang out in a region between Mars and Jupiter called the asteroid belt. Think of it like a giant cosmic highway with lots of rocks zipping around. And comets are like icy snowballs that travel around the sun in long elliptical orbits. When they get close to the sun, the heat vaporizes some of the ice, creating a beautiful glowing tail that can stretch for millions of kilometers.
So we have planets, moons, asteroids, and comets all moving around the sun in our solar system. It's like a giant cosmic dance party. But what about beyond our solar system? Are there other solar systems out there?
That's where things get really mind-blowing. Our solar system is just a tiny part of a much larger structure called a galaxy. Our galaxy is called the Milky Way, and it contains billions of stars, many of which probably have their own planets orbiting them. And get this, the Milky Way is just one of billions of galaxies in the universe.
Billions of galaxies, each with billions of stars. My brain is about to explode. But wait, what exactly is a galaxy?
That's a great question. A galaxy is a huge collection of stars, gas, dust, and dark matter, all held together by gravity. Think of it like a giant city of stars with everything swirling and moving around a central point. Our solar system is located in one of the spiral arms of the Milky Way Galaxy. We're kind of like a tiny neighborhood on the outskirts of this giant star city.
Okay, I think I'm starting to get it. So our solar system is in the Milky Way Galaxy, and there are billions of other galaxies out there. That's incredible. This is so much information to take in. I need a minute to process it all.
I know, it's a lot to think about, but that's what makes space so fascinating. There's always something new to discover and learn.
You're right. This is amazing. I can't wait to learn more. But for now, let's take a quick break and come back to explore even more incredible facts about our universe.
Welcome back, space explorers. Ready for round 2 of our cosmic journey?
Definitely. Last time we left off talking about all the different planets, from tiny Mercury to that giant Jupiter.
Right, those gas giants.
Yeah, those were pretty wild. But can we, go back and explore each one a little more? Kind of want to know what makes each planet so special, you know?
Of course, happy to dive deeper. Let's start with Mercury, the smallest planet and the closest to the sun. It's a rocky world, lots of craters, kind of like our moon, actually. And because it's so close to the sun, Mercury gets super hot during the day. But then, get this, it gets freezing cold at night.
Whoa, really? So it's like a planet at extremes. Hot, 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 then freezing.
Exactly, a planet of contrasts. Now, onto Venus. We talked about it being super hot with that toxic atmosphere.
Yeah, I remember you said it's even hotter than Mercury. But why is that? If Mercury's closer to the sun, shouldn't it be hotter?
You would think so, but Venus is actually the hottest planet in our solar system, even hotter than Mercury. That's because of something called the greenhouse effect.
Greenhouse effect. Like for plants.
Well, similar concept, but on a planetary scale. Imagine a car parked in the sun with all the windows rolled up, the heat gets trapped inside, and it gets super hot, right?
Yeah, like an oven.
Exactly. That's kind of what's happening on Venus. Its atmosphere is thick and full of carbon dioxide, a gas that traps heat. So the heat from the sun gets trapped by the atmosphere, making Venus a scorching inferno.
Wow, so Venus is like a giant oven. Definitely not a place I'd want to visit. Okay, next up is Earth. Home sweet home. What makes our planet so special compared to all the others?
Well, Earth is unique because it has all the right ingredients for life as we know it. Liquid water, a breathable atmosphere with oxygen, and that comfortable temperature range, all thanks to our atmosphere and just the right distance from the sun.
So we're really lucky to be here.
Absolutely. Earth is in what we call the habitable zone, not too hot, not too cold, like Goldilocks, just right.
Okay, next is Mars, the red planet. I remember you saying it gets its red color from rust in the soil.
That's right. Iron oxide, or rust, gives it that distinct reddish hue.
Cool. But is there really a chance there was once life on Mars, like way back when?
Scientists believe it's possible. Mars might have been much warmer and wetter billions of years ago, possibly even capable of supporting some form of life.
No way. So there could have been like little Martians running around.
We're still searching for clues. There are robotic rovers exploring the surface of Mars right now, looking for evidence of ancient life. Maybe they'll find fossils of tiny Martian creatures, who knows?
That would be amazing. Okay, time to talk about the gas giants. Jupiter, Saturn, Uranus, and Neptune. What's it like inside a gas giant? Is it just like one big cloud?
That's a question that keeps scientists busy. Gas giants are mostly made of hydrogen and helium, just like the sun, but their interiors are more complex than just a giant cloud. Deep down inside, they probably have a solid core, though we're not entirely sure what it's made of. It's a bit of a mystery.
A solid core. But they're made of gas, right?
Mostly gas, but it's like a giant layered cake with different ingredients and pressures as you go deeper.
Okay, I'm trying to picture that. So Jupiter's the biggest, and Saturn has those beautiful rings.
Absolutely stunning, those rings.
Yeah, they are. But what about Uranus and Neptune? What makes them special?
Well, Uranus is a bit of an oddball. It's tilted on its side, almost like it got knocked over. This tilt gives it some very extreme seasons. Imagine having summer for 21 years, then winter for another 21 years.
Wow, 21 years of summer. That's a long vacation.
And then Neptune, well, it's known for that intense blue color caused by methane gas in its atmosphere. And it has incredibly strong winds, the strongest in the solar system, whipping around at supersonic speeds.
Those gas giants are definitely full of surprises. You also mentioned that there are moons orbiting the planets. Are they all like our moon?
Not at all. There's a crazy variety of moons in our solar system, each with its own unique features. Some are icy, some are rocky, and some are even volcanically active.
Whoa, really? Volcanoes on a moon?
Absolutely. For example, Jupiter's moon Io is the most volcanically active body in our solar system, with volcanoes constantly erupting and spewing lava. And then there's Saturn's moon Titan.
What's special about Titan?
Titan has a thick atmosphere and lakes of liquid methane. Imagine that. It's one of the most intriguing places to search for signs of life beyond Earth.
Volcanoes on Io and methane lakes on Titan? Our solar system is way more interesting than I thought. Speaking of interesting places, what about Pluto? I know it used to be considered a planet, but now it's a dwarf planet. What happened?
Pluto. A bit of a cosmic demotion. It all comes down to how we define a planet. According to scientists, a planet has to meet 3 criteria.
3 criteria. What are they?
First, it must orbit the sun. Second, it must be massive enough for its own gravity to make it round. And third, it must have cleared its neighborhood of other objects in its orbit.
Cleared its neighborhood.
It means a planet's gravity has to be strong enough to either pull in or fling away any other objects in its path. So it's the dominant object in its orbit. Pluto meets the first two criteria, but it shares its orbit with a bunch of other objects in a region called the Kuiper Belt.
So it's got too many neighbors.
Exactly, and that's why Pluto got reclassified as a dwarf planet. Still a fascinating world, just not officially a planet anymore.
So Pluto's like a little rebel hanging out with its friends in the Kuiper Belt. Okay, we've explored all the planets and even Pluto. But you mentioned earlier that our solar system is in the Milky Way Galaxy, and there are billions of other galaxies out there. Can you tell me more about galaxies? What do they look like?
Of course. Remember how we talked about a galaxy being like a giant city of stars? Well, there are different types of galaxies, just like there are different types of cities. Our galaxy, the Milky Way, is a spiral galaxy.
Spiral.
It has a central bulge with spiral arms extending outward, kind of like a pinwheel. Beautiful structures, really.
So are all galaxies spiral-shaped?
Not at all. Besides spirals like the Milky Way, there are elliptical galaxies, which are smooth and oval-shaped, and then there are irregular galaxies, which have, well, no defined shape at all. And they come in all different sizes, from dwarf galaxies with just a few million stars to giant galaxies with trillions of stars.
Wow, a few million to trillions. That's a huge difference. So if there are billions of galaxies out there, and each galaxy has billions of stars, does that mean there could be billions of planets, too?
That's a very logical conclusion.
And maybe even billions of planets that could support life.
That's one of the most exciting questions in astronomy. We're just starting to explore this vast universe, and with each new discovery, we realize how much more there is to learn. The search for life beyond Earth, well, it's one of those fascinating frontiers in science. Who knows what we might find in the years to come?
Okay, so we've explored our solar system, talked about all kinds of planets and moons, and even touched on the vastness of galaxies. But now I have, like, the ultimate question. What is the universe? Like, is it just everything? Everything that exists?
You know, that's actually a really good way to put it. The universe is everything. All the matter and energy, all the planets and stars and galaxies, all of space, and even all of time. It's everything we can see and everything we can't see. Pretty mind-boggling, huh?
Yeah, my brain is already hurting a little. So, does the universe have an edge? Like if you kept traveling in a spaceship in one direction forever, would you eventually hit a wall or something?
That's one of the biggest mysteries in science. We actually don't know if the universe has an edge. Some scientists think it might be infinite.
Infinite.
Which means it just goes on forever in all directions, no end. But others think it could be finite, meaning it has a size, but unbounded.
Wait, finite but unbounded, what does that mean?
Okay, imagine an ant crawling on a giant ball. It could walk forever in any direction and never reach an edge, right?
Yeah, I guess so.
That's because the surface of the ball is finite, it has a limited size,
Yeah.
but it's also unbounded, it doesn't have an edge. So some scientists think the universe might be kind of like that.
Wow, that is so hard to wrap my head around. So we don't know if the universe goes on forever or if it's like a giant ball. Okay, well, what about how old the universe is?
Good question. Scientists estimate that the universe is about 13.8 billion years old.
13.8 billion. That's like way older than anything I can imagine.
It's an incredibly long time. And we figured this out by studying something called the cosmic microwave background radiation.
Cosmic microwave background radiation. That sounds super complicated.
It is a bit complicated, but basically it's like a faint afterglow of the Big Bang.
The Big Bang. Oh yeah, the event that started the whole universe, right?
Exactly. Scientists believe the Big Bang is what started everything. And this radiation is like the heat and light left over from that event, but, you know, on a cosmic scale.
So the Big Bang is like the universe's birthday.
Yeah.
And then it's been expanding ever since.
Exactly. The Big Bang theory suggests that the universe started from this incredibly hot, dense state and has been expanding and cooling ever since. And we know it's still expanding because, well, we can observe the light from distant galaxies.
Wait, so we can tell the universe is expanding just by looking at the light from galaxies. How does that work?
Well, the light from these faraway galaxies is stretched out, what we call redshifted. It's similar to how the sound of a siren changes as an ambulance drives past you. As the ambulance moves away, the sound waves stretch out, making the siren sound lower. In the same way as galaxies move away from us, the light waves coming from them stretch out, making the light appear redder.
Ah, so it's like the light waves are getting stretched as the universe expands.
Yeah.
So we can actually see that it's getting bigger all the time.
Precisely. It's pretty amazing when you think about it.
So is the universe going to keep expanding forever? Or will it, like, stop at some point?
That's another great question that scientists are still trying to answer. We know that the universe is currently expanding, and it's even accelerating, getting faster, actually. And the force driving this accelerated expansion is something we call dark energy.
Dark energy. Is that the same as dark matter? You mentioned that before.
They're both called dark, but they're different things. Dark matter is something we can't see directly, but we know it's there because of its gravity. It's like an invisible glue holding galaxies together. Dark energy, on the other hand, is this mysterious force that seems to be pushing everything in the universe apart, making it expand faster and faster.
Wow, so dark matter holds things together and dark energy pushes them apart. Space is full of weird stuff.
Right.
Okay, last question. Are there things out there in the universe besides galaxies? Like, what else is there?
Well, besides those beautiful galaxies, we also have black holes. They are regions of space-time where gravity is so strong that nothing, not even light, can escape.
Black holes. They sound terrifying.
They're definitely powerful objects, but they're not like cosmic vacuum cleaners sucking up everything around them. They only pull in things that get too close.
Okay, that makes me feel a little better. Wow, we've learned so much today about the universe, and it's amazing how much we still don't know. Thanks for taking us on this deep dive into space. It's been truly out of this world.
My pleasure. Remember, there's always more to discover. Keep looking up at the stars and never stop asking questions.
That's great advice. To all our listeners, keep exploring, keep learning, and keep wondering about this amazing universe we live in. Until next time, Space Explorers. Welcome to our deep dive into the cosmos. We're going on a journey through space today,
Oh, this will be fun.
exploring everything from, those familiar constellations
Yeah.
to the farthest reaches of our solar system and even beyond.
Exciting.
Yeah, I was looking through your notes earlier.
Yeah.
It's amazing what we can learn about the universe from just our own backyards,
It really is just looking up at the night sky. It's
Yeah.
like we can start unraveling all these mysteries of the cosmos.
Absolutely. And speaking of the night sky, let's talk about constellations.
Okay.
Those patterns of stars
Right.
that have captivated humans for centuries, right?
You're absolutely, yeah.
I was reading through your notes, and you have a bunch of familiar ones in here, like Orion, Canis Major, and Taurus.
Yeah, some of the most recognizable constellations, for sure.
Yeah.
Visible from both hemispheres, actually.
Oh, wow.
And what I think is fascinating is how different cultures have interpreted these same patterns,
Right, interesting.
weaving their own stories and myths into the celestial tapestry.
I love that. So it's like the same sky,
Right.
but different cultures see different pictures.
Exactly.
Yeah, I love that.
Like you mentioned Orion, for example,
Yeah.
often depicted as a hunter
Right.
in Western cultures, but in Indian astronomy,
Yeah.
the bright red star in Orion's shoulder, Betelgeuse,
Yeah.
it's known as Ardra.
Ardra.
Yeah.
Okay, cool. And then
And the Pleiades star cluster, which is part of the Taurus constellation, that's called Kritika in the Indian system.
Pika.
Yeah, it's like looking at the same painting but seeing different images emerge.
Right.
Just depends on your perspective.
Wow.
It really shows how, humans have always sought to find meaning and connect with the universe.
Yeah.
Even if those connections are different across cultures.
Love that.
Yeah.
And it reminds us that science and storytelling have always been intertwined,
Absolutely.
especially when it comes to the stars.
For sure.
Now, you also have something here about the Big Dipper
Okay.
and how it's used for navigation.
Right.
Can you explain that?
Sure. So the Big Dipper, it's a well-known asterism.
Asterism.
Yeah, so that's a recognizable pattern of stars that's not an official constellation itself.
Okay.
It's actually part of the constellation Ursa Major, the Great Bear.
Ursa Major.
But what makes it so useful for navigation is that it helps us find the North Star, Polaris.
Oh, okay. I've heard of Polaris.
Yeah.
But how do you actually find it using the Big Dipper?
Well, if you look at the two stars at the end of the Big Dipper's bowl,
Okay.
they point almost directly to Polaris, which is located at the end of the Little Dipper's handle.
Little Dipper.
Yeah.
Gotcha.
And Polaris appears stationary in the night sky because it's aligned with Earth's axis of rotation.
So if you can find the Big Dipper,
Yeah.
you can find north.
You got it.
That's pretty handy.
Especially if you're, out exploring nature.
Without a compass. Now, you also have a note here about light pollution.
Mm-hmm.
What is that?
So light pollution is basically excessive artificial light at night.
Okay.
So think streetlights, billboards, all those brightly lit buildings in cities.
Yeah.
All that light washes out the fainter stars, making it harder to see the beauty of the night sky.
Oh, that's a bummer. So what can we do about it?
Well, there's a growing movement to create dark sky reserves.
Okay.
And those are areas where light pollution is strictly controlled.
Nice.
They offer incredible views of the night sky, and they help protect nocturnal wildlife that depends on darkness to survive.
That sounds like a great initiative.
Yeah.
Now, for those of us who might not live near a dark sky reserve,
Right.
what are some tools we can use to get a better view of the stars?
There are some fantastic apps out there like Sky Map and Stellarium.
Okay.
They use your phone's GPS to show you exactly what's visible in your location at any given time.
Cool.
So that includes constellations, planets, even satellites.
It's like having a personal guide to the night sky in your pocket.
Exactly.
Okay, that's definitely going on my phone tonight.
Awesome.
Now, let's shift gears and talk about our cosmic neighborhood,
Okay.
the solar system.
Excellent. And of course, the heart of our solar system is the sun,
Yes.
a massive star that dwarfs our planet.
It does.
In fact, the sun's diameter is over 100 times greater than Earth's.
Oh, wow. That's insane. You also have it down here that the sun is 150 million kilometers away from Earth.
It's a long way.
It's hard to even imagine such vast distances.
I know, right?
Yeah.
That's where the astronomical unit, or AU, comes in handy.
Astronomical unit.
Yeah. So 1 AU is the average distance between Earth and the sun. So when we talk about other stars being thousands or even millions of AU away,
Right.
it helps put those distances into a more manageable perspective.
Right. So when we hear that Proxima Centauri, the closest star to our sun, is over 269,000 AU away.
Yeah.
It means it's over 269,000 times farther from us than the sun is.
That's right.
It's truly mind-boggling.
Okay.
But back to our solar system, what about the planets?
Okay.
We've got 8, right?
That's right. And it's interesting to note that in Indian astronomy, some of these planets have different names, reflecting their cultural significance.
Okay.
For example, Mercury is known as Buddha,
Buddha.
and Venus is called Shukra.
Shukra.
It's like nicknames for our cosmic neighbors.
I like that.
Yeah.
Now, give me the highlights.
Okay.
What makes each of these planets stand out?
Well, Venus, for example, is often called the morning star or evening star because it's the brightest object in the sky after the sun and moon.
Wow.
It's so bright that it's often mistaken for a UFO.
Huh. I could see how that would happen.
Yeah.
Now, what about Mars? It's always fascinated me with its reddish color.
Yeah, Mars is indeed known as the red planet because of the iron oxide or rust on its surface.
Rust. Wow.
And of course, we can't forget Earth, our own blue planet, the only known planet in our solar system to harbor life as we know it.
Speaking of life, what about those gas giants?
Okay.
Jupiter, Saturn, Uranus, and Neptune.
Right.
I remember seeing pictures of them in school.
Yeah.
And they were always so different from the rocky planets.
The gas giants are truly colossal. They're composed mainly of gases like hydrogen and helium.
Okay.
And they have incredible ring systems made up of countless particles of ice and rock.
Oh, wow.
Saturn's rings are particularly spectacular.
Yeah.
Easy to see, even with a small telescope.
Oh, I bet that's a sight to see.
Yeah, it is.
Now, I have to ask about Pluto.
Okay.
I remember learning it was a planet when I was a kid, but then it got demoted.
Right.
What happened there?
So Pluto's a fascinating case.
Yeah.
See, in 2006, the International Astronomical Union, or IAU, decided to redefine what it means to be a planet.
Oh, okay.
They came up with 3 criteria.
Right.
A planet has to orbit the sun
Uh-huh.
It has to be massive enough to be rounded by its own gravity.
Right.
And it has to have cleared its orbital path of other debris.
So Pluto didn't make the cut.
It met the first two criteria, but it struggles with the third one.
Okay.
It shares its orbital space with other objects in the Kuiper Belt, a region beyond Neptune.
Kuiper Belt.
Yeah, filled with icy bodies.
Wow.
So Pluto was reclassified as a dwarf planet,
Okay.
along with other similarly sized objects out there.
So it's like a planetary little league or something.
Right, exactly.
I like that.
It's still out there.
Yeah.
Just in a different category.
Now, realistically, how many of these planets can we actually see with the naked eye?
You can actually spot 5 planets without any special equipment.
Really?
Venus, Mercury, Mars, Jupiter, and Saturn.
Okay.
Venus and Jupiter are usually the easiest to find,
Yeah.
as they often appear as bright, star-like objects in the evening or early morning sky.
That's cool. I'm definitely going to try and spot them.
Yeah, it's fun.
But to see things like Saturn's rings,
Right.
I'd need a telescope.
A telescope, or even a good pair of binoculars, can dramatically enhance your stargazing experience,
Yeah.
revealing details you wouldn't be able to see otherwise.
Noted. Okay, we've talked about planets,
Right.
but planets aren't the only things orbiting the sun.
Nope.
Let's talk about moons.
Okay. Moons are fascinating objects in their own right. They orbit planets, just like planets orbit the sun.
Right.
And some of them are quite large, even bigger than our own moon.
Speaking of our moon, it's the only moon we have, right?
Yes, Earth has one moon,
Okay.
and it plays a crucial role in influencing our tides and stabilizing Earth's rotation.
Wow. Okay.
It's hard to imagine our planet without it.
It makes you appreciate how interconnected everything is, even in space.
Absolutely.
Now, what about the other planets?
Yeah.
How many moons do they have?
The number of moons varies greatly.
Okay.
Mars has 2 small moons, Phobos and Deimos,
Phobos and Deimos.
while the gas giants have dozens, even hundreds of moons.
Wow, that's wild.
Yeah.
I also see that India has been quite active in lunar exploration with the Chandrayaan missions.
Absolutely. India's space program has made significant contributions to our understanding of the moon.
Yeah.
In fact, just recently, Chandrayaan-3 made a successful landing near the moon's south pole,
Wow.
a major achievement for India's space agency.
That's incredible. I read that India even declared August 23rd as National Space Day to commemorate the Chandrayaan-3 landing.
Yeah, that's right.
That's awesome. And with Chandrayaan-4 on the horizon, there's a lot to look forward to from India's lunar endeavors.
It's an exciting time for space exploration, that's for sure.
It really is.
Wow.
Now, we've talked about planets and moons,
Yeah,
but what about those other objects zipping around our solar system?
right.
Asteroids and comets.
Okay, so asteroids are essentially rocky remnants from the early solar system, often irregularly shaped and ranging in size from tiny pebbles to hundreds of kilometers across.
Oh, wow. And where do they hang out?
Well, many of them are concentrated in the asteroid belt.
Asteroid belt?
Yeah, a region between Mars and Jupiter.
Gotcha.
Imagine it as a cosmic highway
Okay.
with millions of these rocky bodies whizzing around.
Well, that's a lot of space rocks.
Oh!
What about comets?
Comets are like cosmic snowballs composed of dust, gas, rock, and ice.
Okay.
And they're known for their distinctive tails,
Yeah.
which form as they approach the sun
Okay.
and the ice starts to vaporize.
Ah, so those tails are trails of vaporized ice. That's so cool. And I see a familiar name here,
Uh-huh.
Halley's Comet.
Yes. Halley's Comet is perhaps the most famous comet visible from Earth roughly every 76 years.
Oh, wow.
Its appearances have been documented for centuries,
Wow.
and cultures around the world have woven it into their myths and legends.
It's like a celestial celebrity
think so.
making a grand appearance every few decades.
Right.
And speaking of celestial objects with long histories,
Okay.
you have a note here about the Milky Way,
Yes,
which I know is our galaxy,
it is.
but you also have the name Akashaganga.
Akashaganga.
What's that all about?
So it's the Sanskrit name for the Milky Way, meaning Ganges of the heavens.
Ganges of the heavens.
Yeah, it's a beautiful name that reflects the Milky Way's appearance
Okay.
as a faint band of light across the night sky,
Huh.
resembling a celestial river flowing through the cosmos.
It's like our own galaxy has a poetic nickname.
It does.
So can you see the Milky Way with the naked eye?
Absolutely. If you're away from city lights on a clear night,
Yeah.
you can see the Milky Way stretching across the sky.
Wow.
It's a breathtaking sight and a reminder that our solar system is just a tiny part of a much vaster galactic structure.
It's almost like seeing a glimpse of the universe's backbone.
That's a great way to put it.
Now, speaking of seeing things in the night sky,
Okay.
I'm curious about observatories.
Right.
I know they're used for astronomical research, but what makes them so special?
Observatories are designed to provide optimal conditions for observing celestial objects.
Right.
They're often located in remote areas with minimal light pollution.
And they house powerful telescopes.
Yes.
That can peer deep into the cosmos,
Wow.
revealing details we could never see with the naked eye.
And you have some information here about the Indian Astronomical Observatory, located high in the Himalayas.
Yeah, the Indian Astronomical Observatory in Hundal, Ladakh,
Okay.
is situated on a peak renamed Mount Saraswati.
Mount Saraswati.
It boasts one of the highest astronomical sites in the world,
Wow.
offering incredibly clear views of the night sky.
Being that high up must give you an incredible perspective on the universe.
It does.
What kind of research do they do there?
They study a wide range of astronomical phenomena,
Okay.
from stars and galaxies to planets and comets.
Oh, wow.
And they even have a dark sky reserve established nearby
Nice.
to protect those pristine night skies from light pollution.
That's fantastic. I'm sensing a theme here.
Yeah.
Preserving darkness seems to be crucial for both scientific observation and simply appreciating the beauty of the night sky.
It is, absolutely.
Yeah, awesome. And with the growing threat of light pollution, it's more important than ever to protect these pockets of darkness
Yeah,
where we can connect with the cosmos and continue unraveling its mysteries.
well said.
Thanks. Welcome back to our cosmic adventure.
Whoa, what a ride.
I know, right?
We've explored constellations,
Yeah.
journeyed through our solar system, and even touched upon that vastness of the Milky Way.
It's a lot to take in, that's for sure.
It is. Now get ready to expand your perspective even further as we venture beyond our galactic neighborhood.
Sounds good. I'm ready.
Okay, so we talked about the Milky Way being a spiral galaxy, but I know there are other types of galaxies out there. Right?
You are absolutely right.
Okay, cool.
Our Milky Way, it's just one of billions upon billions of galaxies
Wow.
scattered throughout the observable universe.
That's incredible.
And just like snowflakes, no two galaxies are exactly alike.
So what other kinds of like galactic shapes are there? Is our Milky Way a typical example?
Well, aside from spirals like the Milky Way,
There are elliptical galaxies, which are more rounded, kind of oval shaped.
okay.
They're like giant cosmic footballs.
Oh, wow.
And then there are irregular galaxies,
Irregular, okay.
which, as the name suggests, they have no defined shape.
Oh, really?
They're kind of like the rebels of the galactic world.
It sounds like a cosmic zoo of shapes and sizes.
It really is.
What determines the shape of a galaxy anyway?
Well, it's a complex interplay of factors.
Okay.
You know, gravity, the distribution of dark matter.
Dark matter.
Yeah.
That sounds like something straight out of a science fiction movie.
It's a bit of a mystery, but we know it exists
Okay.
because of its gravitational effects on visible matter,
Okay.
like stars and galaxies.
Oh, yeah, right.
Think of it like this.
Okay.
Imagine you're watching a puppet show,
Uh-huh.
but you can only see the puppets, not the puppeteer.
Okay.
You know someone is controlling the puppets, even though you can't see them directly.
Right, yeah. Dark matter is like the invisible puppeteer of the universe, shaping galaxies from behind the scenes.
That's incredible. And speaking of incredible,
Yeah.
I have to ask about something that's always fascinated me.
Okay.
The possibility of life beyond Earth. With all these billions of galaxies out there,
Yeah.
are there other planets like ours?
That's one of the biggest questions driving astronomical research today.
I bet.
And the good news is that the search for exoplanets, which are planets orbiting other stars,
Okay.
has been incredibly successful in recent years.
So we're actually finding planets around other stars.
Yeah, we are.
That's amazing. But how do we even find them? I mean, they must be incredibly faint and far away.
Astronomers have developed some really clever methods for detecting exoplanets, even though we can't see them directly.
Right.
One method is called the transit method,
Transit method.
where we observe a slight dip in a star's brightness
Okay.
as a planet passes in front of it.
So it's like a miniature eclipse, with the planet blocking a tiny bit of the star's light.
You got it.
That's so cool.
Yeah,
And by analyzing those dips in brightness,
right.
astronomers can determine the size and orbital period of the exoplanet.
That's right.
That's so ingenious. Are there any other methods for finding these distant worlds?
Another method is called the radial velocity method,
Radial velocity method.
where we measure the wobble of a star
Okay.
caused by the gravitational pull of an orbiting planet.
Oh, okay.
It's kind of like a cosmic dance with the star and planet tugging on each other.
So the more massive the planet, the bigger the wobble it causes in its star.
Precisely.
Wow.
And by analyzing those wobbles, astronomers can determine the mass and orbital characteristics of the exoplanet.
It seems like the more we learn about the universe, the more questions we have.
It's true.
It's an endless cycle of discovery.
That's the beauty of it. Astronomy is all about pushing the boundaries of our knowledge and constantly seeking answers to the most fundamental questions about our existence.
It's humbling to realize that we're just a tiny speck in this vast and ancient universe.
It is.
But it's also incredibly inspiring to think about all the possibilities that lie out there waiting to be discovered.
Absolutely. And with all the incredible advancements in technology, who knows what incredible wonders await us as we continue to explore the cosmos.
Right.
We might find evidence of life on other planets, or perhaps we'll unlock the secrets of dark matter and dark energy.
The possibilities are endless.
They are.
It's almost too much to comprehend.
It is. But that's what makes astronomy so captivating.
Yeah.
And remember, you don't need a fancy telescope or a degree in astrophysics to appreciate the wonders of the universe.
That's a good point.
Simply looking up at the night sky can be a truly awe-inspiring experience.
That's a great point. Sometimes I get so caught up in the scientific details that I forget the simple joy of stargazing.
It's easy to do.
Yeah.
It's a reminder that we're all connected to this vast cosmic tapestry.
Exactly.
Yeah.
And whether you're an armchair astronomer or a seasoned stargazer, the universe has something to offer everyone.
Absolutely.
Well said. But before we get too lost in the cosmic vastness, let's take a moment to reflect on what we've learned so far.
Okay.
We've journeyed from our solar system's familiar planets to the mind-boggling scale of galaxies and the possibility of life beyond Earth.
We've covered a lot.
We have.
And we've only just scratched the surface. There's so much more to explore, from the life cycles of stars to the mysteries of black holes.
I'm ready for more. Bring on the next cosmic revelation. Welcome back to our deep dive into the cosmos. We've explored pretty much everything.
We have, yeah.
From familiar constellations to the mind-boggling scale of galaxies.
It's a lot.
And the possibility of life beyond Earth.
It really is.
I have to say, it's both exhilarating and humbling to realize how much we still don't know about the cosmos.
Absolutely. The universe is full of mysteries, and that's, that's what makes astronomy so captivating.
It is.
It's a never-ending quest for knowledge, a journey of discovery that's been going on for centuries.
You know, it's so easy to get caught up in the complexities of astronomy, all the scientific jargon and theories. That sometimes I just like to, step outside on a clear night.
Yeah.
And just look up at the stars.
There's something truly magical about stargazing, isn't there?
There is.
It connects us to something much bigger than ourselves.
Yeah.
To the vastness of the cosmos and the mysteries it holds.
It's like a reminder that we're part of something ancient and awe-inspiring.
I agree.
And, you don't need a fancy telescope or a degree in astrophysics to appreciate the beauty of the night sky.
Exactly. Even with the naked eye, we can observe the wonders of the cosmos. We can track the movements of planets, marvel at meteor showers streaking across the darkness, and identify constellations that have guided humans for millennia.
That's awesome.
Yeah.
It makes you realize that astronomy is for everyone.
It really is.
Not just scientists.
For sure.
It's a shared human experience.
It is.
A way to connect with the universe and our place within it.
And as we continue to explore the cosmos, who knows what incredible discoveries await us, right?
I know.
We might find definitive evidence of life on other planets.
That would be amazing.
Or, perhaps we'll unravel the enigma of dark matter and dark energy.
Or maybe we'll stumble upon something completely unexpected, something that, revolutionizes our understanding of the universe.
It's possible.
The possibilities are truly endless.
They are.
And that's what makes this field so exciting,
Absolutely.
There's always something new to learn.
Yeah.
Always a new mystery to unravel.
It's a never-ending adventure.
It is.
Exploration.
Driven by curiosity.
Ingenuity.
And a profound sense of wonder.
Well said. And on that note, I think it's time to wrap up our cosmic deep dive.
Yeah, we've covered a lot of ground today.
From the familiar constellations above our heads to the farthest reaches of the observable universe.
We've explored the wonders of our solar system, delved into the mysteries of galaxies, and pondered the possibility of life beyond Earth.
It's been quite a journey.
But most importantly, we've hopefully sparked a sense of curiosity and awe in you, our listener.
Yes.
The universe is full of wonders just waiting to be discovered.
So the next time you find yourself under a clear night sky,
Yeah.
take a moment to look up and let your imagination soar among the stars.
Who knows what you might discover?
Thanks for joining us on this incredible journey through the cosmos.